humans have harnessed energy's power to shape our life on Earth. But have we gone too far? Are we about to destroy humanity and the Earth in the process?
During the Industrial Revolution, oil, gas, and coal were being burned for industrial use.
As a result, humans began to burn more and more hydrocarbons, releasing innumerable amounts of carbon dioxide into the atmosphere. Today, levels of carbon dioxide are still rising because of fossil fuels. As the Arctic absorbs more CO2, the surrounding water becomes more acidic.
With tech companies like Amazon initiating a zero-emissions pledge, how can we solve this problem not only to save humanity, but to open the doors to technology of a utopian-like world? First, let's ask our friend Mother Nature what the quantum mechanics of global warming is like. The light spectrum is the underlying principle of global warming, but how?
In order for an electron to get excited to a new energy level, the atom must absorb specific energy from light to excite the electron to the new level. The rest of the energy levels that light brings will pass through the atom.
But what about CO2? What type of light does CO2 like?
The answer doesn't lie in the sun, but rather the Earth itself. The Earth emits infrared light that is not visible to the human eye. CO2 gases like to choose infrared lights as their energy. When CO2 absorbs infrared light, the electron in the atom falls back to its original energy level, releasing a photon. This photon from countless CO2 molecules in the atmosphere releases some energy that causes global warming.
So what is Mother Nature's natural mechanisms to fight increasing CO2 levels?
Mother Nature uses a mechanism called photosynthesis, where carbon dioxide, along with water and sunlight, is converted into energy for the plants. Through photosynthesis, algae can split water into hydrogen. This process can be optimized through a bioreactor where microalgae are grown to lessen the carbon dioxide levels in the atmosphere. Through a complex process, electrons must reduce NADP+ to NADPH. To attain the electron's goal, the highly efficient photosynthetic process utilizes a trick from quantum mechanics called superposition. This sounds like an absolute nightmare, but the wonders of superposition are going to ensure the electron's path. Through superposition, the electron can navigate all possible paths through the maze of chlorophyll bridges to reach the reaction site. By using photosynthesis as a template, scientists have been able to develop artificial photosynthesis, which converts carbon dioxide into hydrogen. A fuel cell can produce an exothermic reaction where hydrogen and oxygen is converted through a catalyst into clean energy such as water and heat.
Through all this new technology, how are we going to power it in an environmentally friendly way?
The answer? The Planck-Einstein equation and Albert Einstein's photoelectric effect. Through the use of the photoelectric effect, scientists have been able to model a new form of harvesting energy through solar panels. Through the workings of melted silicon, an electrical current is able to power a hydrogen electrolyzer and fuel cell.
From the quantum mechanics of photosynthesis to the electromagnetism of light, new technology like hydrogen cars and rockets are on a path to utilizing zero-emission energy.